I've got the power.
Hey there, welcome to the final DAQ lab, Renewable Energy Measurements of Power.
I've got the power.
Today we'll be looking at quantifying the power of solar, wind, and human power. So what we have here is our solar panel. And our solar panel converts light energy into electrical energy. And we'd like to know the power that our solar panel can generate. So if we think back to our simple circuits relationships, power is equal to current times voltage. So what we first might think to do is measure the current and voltage across these two leads of our solar panel. However, that would give an incorrect result because when we measure current with our multimeter, we use a very low resistance. And when we measure voltage with our multimeter, we have a very high resistance. Therefore, the load is inconsistent in those two measurements and we get an incorrect power measurement. So what we actually want to do is measure the power of our circuit over a constant load, which we'll be using our resistance substitution box to provide. So here we have our solar panel hooked up in a circuit with a resistor. So if we look at the circuit, the leads of the solar panel go into the resistor, across the resistor of the resistance substitution box, and then back out to the solar panel, completing the circuit. And then across the resistor in parallel, we're measuring the voltage. And so if we think about our power relationship, before we said power equals current times voltage. If we use Ohm's law, which is voltage equals current times resistance, we can rewrite power to be voltage squared over resistance. So now all we need to know is what the resistance that we're put in the circuit and the voltage across the circuit, which we measure with our multimeter. In this case, we see about 0.57 volts being generated by the solar panel right now. If I put my hand over the solar panel, we see the voltage drops to 0, and so the power now is 0. And another way we can change the voltage that's coming out of our solar panel is we can change the load in this circuit. So if I adjust the resistance, we see that the voltage goes up and the power will change. So what we'll be doing in this lab will be changing the load in the circuit, so changing the resistance, trying to figure out what the maximum power we get is. And another thing that will change the power is tilting the angle of the solar panel to be more direct into the light. And that will also make the power go up, which we'll be exploring as well. This is our wind energy portion of the lab, and to explore wind energy we'll be using these small computer fans. So a wind turbine works because wind hits the turbine blades, which end up spinning the generator, creating power. However, creating different wind speeds accurately is quite difficult. So we'll actually be looking at the reverse process, where we'll apply electrical power to our fan and create wind energy. And upon analysis of our data, we'll actually see that the two processes are quite similar between a wind turbine and our small electrical fan. So here we have our fan hooked up to the power supply. You can see that our fan is rotating, and we can measure the power we're applying to the fan by taking the voltage of the power supply times the current of the power supply. We can also measure the speed at which the fan is spinning from this third wire that the fan has. Now this third wire outputs a signal at a frequency twice the rotation speed of the fan. And we can actually use our multimeter to measure the frequency of that signal. So if we take this third wire, connect it to our multimeter, and we also need to measure the ground of the power supply. So we can use one of our banana plugs, plug it into the power supply, clip it to our multimeter, set our multimeter to measure frequency, turn our multimeter on, and we see 81 hertz. And if we increase the power to the fan, we see that the fan speed goes up. Our final renewable energy we'll be looking at is human power, which we'll be measuring with this hand bike. So the way the hand bike works is we turn the crank and spins the generator, generating power, and comes out at these two terminals. Now to accurately measure the power of our hand bike, we need to apply some load to our circuit. We could use our resistance substitution boxes again, but to prevent you from getting overheated while you're turning the hand bike, we're going to use the computer fan. So here we have our computer fan hooked up to our hand bike, We see the circuit coming from the generator, going through to the computer fan, back out to the generator. And we'd like to figure out the power that it takes to run our computer fan. So we need to measure power equals voltage times current. We need to measure both voltage and current. First we'll do voltage. Voltage we measure in parallel, so we're just going to clip across these two bare wire connections. We turn on our multimeter and start spinning the hand crank until the fan just barely starts moving. That's the minimum power we need. And then you can go ahead and give it the business to see how much power you can generate. Now to measure power, we still need to measure current. And if we remember, current is measured in series, so what we have to do is break the circuit and measure the current between these 2 points. So now we've hooked up our multimeter in series in the circuit. We're connected to the 10 amp fuse to measure current and appropriately in the multimeter. So if we start turning the crank, we can see the smallest current that we need to start turning the fan. And then again, we can really give it the business to measure our maximum power output. So in summary, this lab we looked at the power of a couple different renewable energy devices. And to figure out what the power was, we applied the equation power equals current times voltage. Now we used Ohm's law to make that relationship into power equals voltage squared over resistance when we used our known resistors for our load. And we used this relationship to figure out what the max power was for our solar panel, and then develop a power versus wind speed relationship for our computer fans, and then finally we wanted to figure out what the maximum power you could generate using the hand bike.